So using the fraction buster techniques allows us to rewrite our equation so that it doesn't have fractions at all, which simplifies the solving process. If I look at this first example, you can see that I have denominators that contain the number 6, and one of the denominators contains the number 8. Now, I could multiply both sides of this equation by the number 6 and by the number 8, and I would eliminate all the fractions in one step. I could also multiply by a slightly smaller number. 6 is 2 times 3, and 8 is 2 times 2 times 2, which you can see I need 3 factors of 2 to get rid of all fractions because this requires it, but I only need a single factor of 3. So I could multiply by 3 times 8, which is 24. That would be a smaller number and it would simplify the process. But I'm just going to go ahead and multiply both sides by 6 times 8, and I'll get the same answer. I just have to reduce it at the end. So both sides of this equation are going to be multiplied by both the numbers 6 and 8. And when I multiply both sides by 6 times 8, I have to push that factor of 6 and 8 across all three of the terms. This equation has two terms on the left-hand side, so this is going to get a 6 times 8. This is going to get a 6 times 8. And over here, there's only one term. This is going to get a 6 times 8. So if I start looking at it, the first step I'm going to do is I'm going to write, hey, I'm going to have a 6 times an 8 times an x over 6. So you can see that red dot that I had was just replaced with a 6 times 8 minus a 6 times an 8 times a 5 all over 8. And that's going to equal, on the other side, 6 times 8 times 4. The important idea here is that because I multiplied every term, this term, well, this term, this term, and this term, by 6 times 8, this equation is still true. These things are still equal to each other, and I'm going to find the same value of x. Now that I've done that, it's time to identify some giant ones and get rid of them. 6 over 6 is the number 1, so that's gone. 8 over 8 is the number 1, so that's gone. So this equation is going to become the much more simplified version. It's going to become 8x minus 6 times 5 is 30. And on the other side, it's going to equal 6 times 8 times 4. 6 times 8 times 4. The other side is going to equal 192. Now, if I look at where we're at now, this form of the equation, right, looks much more simple to deal with than the original form of the equation, yet they're still equivalent to each other and they're going to have the same answer. So let's go ahead and finish this. I'm going to add 30 to both sides. So you see I've got the 192. On each side of this equation, I'm going to add the number 30. When I add 30 to the left-hand side, it's going to become 8x. And when I add 30 to the right-hand side, it's going to become 30 more than 192. It's going to become 222. So it looks like my answer is x is equal to 222 over the number 8. If I was to look at that as a fraction, 222 over 8, apparently it reduces. X is 111 over the number 4. Now I know what you're thinking. Hey, that can't be the answer. Why? Because it doesn't look right. Well, it could be the answer, although it could be wrong too. One other thing I want to look at while we're here is how do I check that this answer is correct? So on our classroom calculators, now that I've got 111 over 4 on the stack, I can ask my calculator to store that as x. And as soon as I do that, this calculator now believes if I say, hey, what's x? This button pulls up the variable. When I say what's x, it says that's 111 over 4. So I want to confirm that the left-hand side and the right-hand side are the same. So I'm going to enter a fraction with an x in the numerator and a 6 in the denominator. And if you look, all I'm doing is I'm just typing this term, right? So I'm writing x over 6. I'm going to leave the denominator, and I'm going to now subtract another fraction. This fraction is going to be 5 over 8. And that's this one. So you can see right now, all I've done is I've just rewritten this entire left-hand side. I've got x over 6 minus 5 over 8. When I press enter, I get the number 4, right? That tells me that this was the correct solution. Why? Because it's the value of x that made both the left-hand side and the right-hand side the same, Namely, it made them both equal to the number 4. One more example of fraction busters. In this one, I've got a denominator that contains my variable. So I'm going to definitely want to multiply both sides of this. If I look at all of the denominators that I have, right, one of my denominators is x, and the other denominator is 8. So I'm going to go ahead and multiply both sides of this equation by 8 times x. And sometimes it's helpful to put 8 times x over 1, so you understand you're not multiplying by 8x over 8x, just 8x over 1. So I'm going to push through those factors, and every single one of the terms, this term, the 2 is going to get it, and this is going to get it. I'm going to give it an 8x for each one of those spots. So let's go ahead and do the next step where I go ahead and push that factor through. So this equation is going to become 8 times x times the 5 over x minus 8x times 2 over 1. And then the other side is going to be minus an 8x times 11 over the 8 that was there. So again, I've identified, or we can identify rather, the giant ones. There's an x over x that can go away. That's gone. Also, there's an 8 over 8 that can go away. That will be gone. So the next thing I'm going to write down is this equation is going to become 40 minus, let's see, 2 times 8 is 16 minus 16x. And that equals, it looks like it's going to be negative 11 times x, negative 11x. All right, so what do I do now? Well, what I do now is I'm going to go ahead and, for clarity, I'm going to box. This is where it's at with no fractions. But we need to do more to this to solve it. So I'm going to go ahead and add 16x to both sides. So when I add 16x to the left-hand side, rather, it's going to become the number 40. And on the other side, I've got negative 11, and I'm going to be adding 16 to that. Negative 11 plus 16 is going to give me exactly 5. So this is going to become a positive 5x. Again, what did I do as I moved from this box to this version? I multiplied both sides. I added 16x to each side. And then finally, I'm going to divide both sides by 5. So 40 over 5 is the number x. And I believe that should be 8, right? If I look at the fraction 40 over 5, it reduces to just the number 8. So x is the number 8. And again, if I want to check that answer, I can come back up and I can say, hey, I'm going to now store that value of x in my calculator. This calculator now believes that x is the number 8. And I'm going to evaluate the original equation. On the one side, I had 5 over x. And I'm going to subtract from that the number 2. So minus the number 2. And what I'm wondering is oops, I did that incorrectly. I got to get out of the denominator. Now I subtract the number 2. And I'm wondering, is that the same as negative 11/8? And you can see it is negative 11/8. So the point is, when I take this value of x and I put it in this side of the equation, I got negative 11 over 8. And the other side was negative 11 over 8. So that is definitely the solution to this equation.